Hello, this is Dr. Bob Brown. Today in this lesson we're going to cover section 7.3, which involves computing trig functions of acute angles. These are some of the topics we're going to cover. We're first going to look at an isosceles right triangle and compute the trig functions for a 45-degree angle, which is pi over 4. And then we're going to find the exact values of the trigonometric functions of pi over 6, which is 30 degrees, and pi over 3, which is 60 degrees. And then we're going to break out our calculator to approximate the value of trigonometric functions of acute angles. In fact, saying approximate may be true, but a good graphical calculator can calculate the value of a trig function to many, many decimal points or decimal places. Then we're going to look at modeling and solving applied problems involving right triangles. So now we're going to find the exact value of trigonometric functions of pi over 4. So let's look at this triangle. It's an isosceles right triangle. If one of the acute angles is 45 degrees and it's a right triangle, then this other angle has to be 45 degrees. And that means that we can build a right triangle with both sides 1. That would be an isosceles right triangle, and then use the Pythagorean theorem to say that c squared is equal to a squared plus b squared. So c squared equals 1 squared plus 1 squared equal to 2. So c, the hypotenuse, is the square root of 2. So now we have a triangle with all 3 sides calculated, and now we can calculate the value of the trigonometric functions. Here we're asked to take this triangle and calculate sine of 45 degrees times tangent of 45 degrees, and then secant of pi over 4 times cotangent of pi over 4. So still looking at our triangle, sine of 45 degrees is opposite over hypotenuse, which is 1 over the square root of 2, which is the square root of 2 over 2. And tangent of 45 degrees is opposite over adjacent, which is 1 over 1. So our answer is the square root of 2 over 2. Now, the secant of pi over 4 would be 1 over cosine of pi over 4. Cosine of pi over 4 would be 1 over the square root of 2. So the reciprocal of that is the square root of 2. And then cotangent of pi over 4 is equal to adjacent over opposite, which is just 1 over 1. So our answer is the square root of 2 times 1 equals the square root of 2. Pretty simple. Now we're going to look at a 30-60 degree right triangle, find the exact values of the trigonometric functions of pi over 6 is 30 degrees, and pi over 3 is 60 degrees. In order to do this, we're going to construct some triangles. The 30-60 triangle looks like this, with the larger acute angle equal to 60 and the other one being 90 minus 60 equals 30 degrees. And let's draw another triangle adjacent to the first triangle that is identical except oriented in the other direction. And when we do this, we have an equilateral triangle with the angle up here being 60 degrees, the angle here being 60 degrees. And notice that since it's an equilateral triangle, this side is going to be 2. And so A is 1, and A over here is 1. So now we have a triangle which we could calculate B, which is the opposite side of the 60-degree angle. And so doing this, we have C squared is equal to A squared plus B squared. And C is 2, so that's 2 squared, equal A squared, which is 1 squared, plus B squared. And we see that this is 4 equal 1 plus B squared. So B squared is equal to 3, and B is the square root of 3. So now we have a 30-60 degree right triangle with all the sides identified. And now we can take this and let's just fill this in. Sine of 30 degrees, sine of 60 degrees is equal to opposite over hypotenuse is equal to the square root of 3 divided by 2. Cosine of 60 degrees is equal to the adjacent over the hypotenuse is equal to 1 over 2. And then finally, let's just write it right here, a tangent of 60 degrees equal opposite over adjacent equals the square root of 3 over 1 equal to square root of 3. And sine of 30 degrees, we could use all kind of methods here. We could say that would be the cosine of 60 degrees, which is 1/2. But let's just say it's going to be sine of 30 degrees is equal to the opposite over the hypotenuse, which is, looking at the triangle here, this is the opposite of the 30-degree angle divided by the hypotenuse, which is equal to 1/2. And Similarly, if you use the other identities, you can complete this table. I would suggest that everybody might want to stop the video now and make sure they can complete it. But here's a summary for pi over 6, pi over 4, and pi over 3, corresponding to 30 degrees, 45 degrees, and 60 degrees. And here are the values of all the trig functions. I would stop now and make sure that you can get the same thing. Now, suppose you wanted to find the exact value of trigonometric expressions given here. Leave it on the next page. We have the solution. Sine of 45 degrees times cosine of 30 degrees. Go back and look at the table. Sine of 45 degrees is the square root of 2 over 2. And the cosine of 30 degrees is the square root of 3 over 2. So multiplying this out, we get the square root of 6 over 4. That can't be further reduced. The tangent of pi over 4 minus sine of pi over 3. Tangent of pi over 4, remember it's a 45 degree angle. The opposite and adjacent are the same. So that would be equal to 1. Sine of pi over 3 happens to be the square root of 3 over 2. And simplifying this, 1 minus the square root of 3 over 2 equal 2 halves minus the square root of 3 over 2. Combining the numerators now, we get 2 minus the square root of 3 over 2. Now we were asked to calculate tangent squared of pi over 6 plus sine squared of pi over 4. Well, tangent of pi over 6, if you look on the previous slide, is equal to the square root of 3 over 3. So that squared would be 3 over 9 equals 1/3. Sine squared of pi over 4, sine of pi over 4 is equal to the square root of 2 over 2. So sine squared of pi over 4 would be, squaring this would be 1/2. So the sum is 1/3 plus 1/2, which is 2/6 plus 3/6 equals 5/6. Now we're going to use a calculator to approximate the values of the trigonometric functions of acute angles. And bringing up our calculator, you need to turn it on, of course, and you need to be in the right mode, depending on whether you're working in degrees or working in radians. So if you turn on the mode, notice right now degrees are highlighted. If you wanted to be working in radians, move the cursor to radians and hit enter, and now you're in radians. Now I believe we're going to work the first problem using degrees, so let's switch it back to degrees. And it's very important that you always have your calculator in the correct mode if you're going to get answers that matter or that are accurate. So we're going to calculate the cosine of 48 degrees, cosecant of 21 degrees, and the tangent of pi over 12. So let's do this. First, we're going to set the mode to take degrees. And we now clear the calculator. We can clear it again if we want to. And type in cosine of 48 degrees. Hit enter. And notice we get 6691, which is rounded off to 0.67. Now we're asked to do cosecant of 21 degrees. And most calculators do not have a cosecant key. So we need to realize that cosecant's 1 over sine. So we now calculate 1 divided by sine of 21 degrees. Hit enter, and we get 2.79 to the nearest hundredth. Now, to calculate tangent of pi over 12, we need to change the mode. So hit mode, and let's go down and set it to radians. Clear the calculator. And now we will do tangent. Notice you can enter pi exactly to second pi divided by 12. Hit enter, and we get 0.2679 rounded off to the nearest hundredth. We get 0.27. Now we're going to use what we've learned about trigonometry to solve applied problems that involve right triangles. The first example we're going to look at is we're going to construct a rain gutter, and you're going to start out with aluminum sheets 12 inches wide, and we're going to bend the sheet up at 4 inches and 8 inches and bend it so many degrees, which is represented by the angle theta. And then we can look at look at two triangles, the one here and the one here, and the rectangle in the middle, and begin to label the hypotenuse is 4, and we're going to call the height of the gutter B, which would be one side of the triangle. So this side would also be B. And we will also call the adjacent side A. And transferring this picture to the next slide, we can begin to fill in the unknown, and we want to write an equation for the total area of the cross section of the gutter. So, looking at this triangle here, which is the right triangle associated with this gutter, we have B, we have A, and we have the hypotenuse is 4. So looking at cosine of theta is adjacent, which is A, over the hypotenuse, which is 4. That means that A is equal to 4 cosine of theta. Sine of theta is opposite over the hypotenuse, which is b over 4. So b is equal to 4 sine of theta. So the area of the triangle over here is 1/2 the base times the height, which is 1/2 a times b. And recall that a is 4 cosine of theta, b is 4 sine of theta. So 4 times 4 is 16, divided by 2 is 8. So the area of a triangle is 8 sine theta cosine of theta. So the area of the two triangles is 16 sine of theta times cosine of theta. And notice that the rectangle has a length of 4 and a height of b. So the area of the rectangle is 4 times b, and b is 4 sine of theta. So the area of the rectangle is 16 sine of theta. So the area of the opening of the gutter is the area of two triangles, which is 16 sine theta cosine theta, plus the area of the rectangle, which is 16 sine theta. Notice we can factor 16 sine theta out, and the total would equal 16 sine of theta times cosine of theta plus 1. Now, we want to see what the area would be for various values of theta. That's the amount that you bend the sheet metal up. For theta equal 30 degrees, A for 30 degrees is 10 sine of 30 degrees times cosine of 30 degrees plus 1. Sine of 30 degrees is a half. Cosine of 30 degrees is the square root of 3 over 2. And then plus 1. Putting this in your calculator, you get 14.93. Similarly, for theta equal 45 degrees, you got 16 sine of 45 degrees times cosine of 45 degrees plus 1. Sine of 45 degrees is the square root of 2 over 2. Cosine of 45 degrees is the square root of 2 over 2. We add all this up and simplify, put it in our calculator, we get 19.3. Now, if theta were 60 degrees, we have 16 sine of 60 degrees is, well, sine of 60 degrees is the square root of 3 over 2. Cosine of 60 degrees is 1/2. Putting all this in your calculator, and we get 20.78. For theta equals 75 degrees, putting sine of 75 degrees in your calculator and cosine of 75 degrees in your calculator and adding it all up, you get 19.45. Now, we want to find the maximum value of the area. And I want to put in our calculator and graph it. So let's bring up the calculator, turn it on, clear it, And we're going to make sure we're in the degree mode. And now we're going to put the formula in. And we need to put 16 sine of theta. Notice it says x, but we really are doing theta. 16 sine of theta. Then another parentheses, which would be cosine of theta, plus 1 in parentheses. Now, let's go set up our window. X min should be, say, 0 degrees. X max should be like 90 degrees. And Y min, which would be the area, let's set it to 0. And notice that our numbers were getting up to like 20 or 30. So let's do a Y max of like 30 and do a graph. And here we see a graph. And the value on the left is 0 for 0 degrees. And you see a value here for 90 degrees. And to find the maximum area and the value of theta corresponding to it, we need to put a trace on. And now calculate the max and hit second, calc. And we want to hit 4 for maximum. It asks for a left bound. We have a left bound there. Hit enter. For the right bound, let's move the cursor over to the right. Hit enter. And when it asks for a guess, you just hit enter. And it says the maximum occurs if you pick 60 degrees. And the maximum is 20.78. And here's the same graph on this slide that we just got. Notice it said 60.1, 2, 3, 4, 5 zeros and a 5. It's really 60 degrees. And the maximum area of the opening would be 20.78461. Now let's work another problem. We're going to find the width of a river here. Notice you have a surveyor that sights a point on the other side of the river and sights a point C on his side of the river. And he's standing here with his transit. And he notices that if he's 200 meters away from point C, he gets an angle looking at the point across the river of 20 degrees. So immediately we can do a calculation on what the distance across the river is. We can go ahead and write down that the tangent of theta is equal opposite over adjacent. which is B over A, which is B over 200, and the angle is 20 degrees. So putting in tangent of 20 degrees, we get, by cross multiplying, that B is equal to 200 tangent of 20 degrees, which is 7279. Let's go do that. Remember, we are in the degree mode. So if we put in 200 tangent of 20, we should get 72.79 is how far it is across the river. Rounding to the nearest meter, it would be 73 meters. Now, I want to give you a couple of definitions. Suppose you're on the ground and you're looking up at an object. I guess that looks like a flying saucer. And if you measure the angle between your line of sight and the horizontal, that's called the angle of elevation. On the other hand, suppose you're on a cliff, I'll say, or top of a canyon, and look at an object on the canyon floor and sight down to the object. The angle between the horizontal and your line of sight is called the angle of depression. So those are just a couple of definitions that you'll need to know to work some of these problems. Simple problem here. Suppose you saw some clouds and you had a transit, and you determined that the angle to the cloud is 75 degrees, and that you knew you were 300 feet away from a point below the clouds. You can then write that h over 300, which is opposite over adjacent, is equal to the tangent of 75 degrees, or h equal 300 tangent 75. Putting this in your calculator, and I'll ask you to do it now, you'll get that the answer is 1119.62 meters, or feet. Now, the last problem we're going to work is you're in a building, you're looking at a building, the Board of Trade in Chicago, and this building has a flag or statue on top of the building, and you take your transit and you're 400 feet below the bottom of the building, look at the top of the statue and the bottom of the statue, and you get angle of elevation to the top of the statue of 56.5 degrees, and to the bottom 55.1 degrees. So if we can figure out what B is and what B prime is, and subtract them, we got the height of the statue. So let's calculate this. We can look at the next page, and we've replicated the triangles here. We can write that tangent of 55.1 degrees is equal to B over 400, and that the tangent of 56.5 degrees is B prime over 400. So B is equal to 400 tangent of 55.1 degrees. Putting this in your calculator gives you 573.39. Calculating B prime, which is 400 tangent of 56.5 degrees, you get 604.33. Subtracting the two, you get that the statue is about 30.94 feet, or rounded off to the nearest foot, about 31 feet. And that is the lesson for today.